And he actually said that that might improve living conditions in harsh environments as we have in Sweden, particularly during the winter. So he was aware of this issue, but I don't think he really believed that it would happen.
We will be tasking for a few moments, so please remain seated.
In the absence of proof, Svante Arrhenius' theories went unheeded for a long time. On the slopes of the world's biggest volcano, the Mauna Loa, in this observatory built at an altitude of 10,000 feet, John Barnes and his colleagues are measuring the levels of CO2 in the atmosphere.
We know CO2 would be higher in cities and other kinds of pollution. We really want to measure the whole globe. And when we measure it here, the level of CO2 is really representing a huge area of the Pacific. So we know it's not just a local influence.
It is here that for the first time, an American oceanographer has been able to measure an unusual rise in the levels of CO2 present in the atmosphere, and to draw a curve which has now become famous, the Keeling curve.
Charles David Keeling started the measurement back in 1958 here at Mauna Loa. And as you can see, just in the first year, it was ramping up. And you can see that it's gone up every year and that the increase is getting faster. And the increase can really only be explained by man-made activities.
Half a century will have to pass, however, before the scientific community could come up with an explanation for this breathtaking rise. Dr. Rajendra Pachauri, Nobel Peace Prize winner in 2007, is the president of the IPCC, the Intergovernmental Panel on Climate Change. The IPCC brings together 2,500 scientists of many nationalities, and their report of 2007 shattered the prevailing dogmas.
Unless there is support, unless there's momentum from the people of every society, carbon dioxide is the cause behind climate change. And therefore, those activities which are emitting carbon dioxide are obviously imposing a cost on the earth, on humanity, on this generation and the next generation. So we have to do something to control the way human beings are emitting greenhouse gases. Otherwise, in the 21st century, the changes will be much worse than what we saw in the 20th century.
Svante Arrhenius was right. Once a month, Christian Vincent and his students ski away from their glaciology lab to monitor the evolution of some of the glaciers of the Mer de Glace. Their program includes core drilling and the installation of beacons at more than 10,000 feet to study the melting and the recession of these valleys of ice.
Si on prend la tendance à long terme, depuis 1850, le glacier de la mer de glace a reculé d'environ 2 km. Sur ces 15 dernières années, le glacier a reculé de 450 mètres.
Scientists observe the melting of ice around the globe, an unquestionable proof that global warming is indeed speeding up.
Les glaciers montrent une tendance très négative avec une perte de masse très marquée et ça traduit directement le réchauffement.
In the basements of the Toulouse Centre of Météo France, a host of computers is building up all sorts of forecasts on the climate of tomorrow and beyond. The results are scenarios of rapid climate change, to which man will find it very difficult to adapt.
Actuellement, d'après les émissions qui ont pu être relevées au cours des 10 dernières années, on sait qu'on se situe sur le scénario le plus haut qui a été imaginé par le GIEC. C'est donc un scénario à très forte émission qui, s'il se produisait, pourrait conduire donc à la partie haute de la fourchette, donc approcher les 5 à 6 degrés de réchauffement suivant les modèles et suivant les projections.
5 to 6 degrees Celsius. This increase of temperatures could well upset the carbon cycle and drag our climate into the unknown. Corinne Lequerre is a world specialist on carbon sinks, a mechanism through which nature absorbs the carbon dioxide of the atmosphere.
One very important thing is that of all the CO2 that is emitted to the atmosphere from fossil fuel emission and deforestation, only 45% remain in the atmosphere, and that's because of the presence of 2 very large sinks, the ocean sink and the terrestrial biosphere sink.
These sinks work like CO2 vacuum cleaners. They balance and regulate our climate. Welcome into the world of the very tiny. Diatoms, dinoflagellates, cyanobacteria, these are some of the species of phytoplankton, microscopic algae which constitute part of an extraordinary deep-sea flora and activate the biological pump. Micro-seaweeds which live by the billions on the surface of the oceans and consume CO2 like the leaves of a tree, thanks to photosynthesis. The food chain takes care of the rest. Once the carbon has been fixed in the cells of the algae is eaten by fish or zooplankton, and when their droppings sink to the seabed, the carbon is returned to the depths of the ocean. An amazing biological mechanism which constitutes the biggest reserve of carbon in the ocean.
S'il n'y avait pas de pompe biologique dans l'océan, il y aurait actuellement 2 fois plus de carbone dans l'atmosphère. C'est-à-dire qu'un océan non vivant, ça serait un effet de serre beaucoup plus important. Donc la pompe biologique est vraiment un processus fondamental pour soustraire du CO2 à l'atmosphère, et on estime que c'est de l'ordre de 90%, les 10% restants étant faits par la pompe dite physique.
Salinity, air temperature, water density. A delicate balance which allows the ocean to capture and dissolve the CO2 of the atmosphere and to send it to the ocean floor using the deep dives mechanism. This is what is called the physical pump. The major deep dives are located in the cold seas of Greenland and Norway and in the Indian Ocean. Vast quantities of CO2 are taken to the seafloor and stay there for thousands of years, caught by the deep currents which cover the sea depths. Just outside Montpellier, the green oaks of the forest of Puy-Chabot hide more than just a few wild boar. Passers-by may well discover an astonishing installation. An impressive series of captors installed at the feet and at the tops of trees, which have for some years now allowed us to study the slightest heartburn of these CO2 big eaters.
La forêt contribue à baisser les taux de CO2 dans l'atmosphère parce qu'elle absorbe du CO2 par le processus de photosynthèse, qui est simplement un processus d'accumulation du CO2. Ça se fait dans les feuilles. Et ça permet à l'arbre d'accumuler du carbone et de grandir.
Very much like the pores of our skin, tree leaves hide minute holes called stomas, which allow them to absorb and store CO2 and to feed on it. Thanks to this biochemical reaction and to the decomposition of the forest soils, forests around the globe, the biosphere, become carbon sinks capable of absorbing nearly 30% of the CO2 present in the atmosphere. Photosynthesis, deep dives, carbon sinks, this amazing machinery is at the center of all life on our planet, and it could well